Hello and welcome students. We have lecture number 3 on continuity. In last two lectures, we have learned the definition and different fundamentals of continuity. In last lecture, I solved few problems. So in question number 1 from exercise 1.1, we have solved first and second question. So this is third part of question number 1. So what we have to do, we have to examine the continuity of the function which is given as follows. At x equals to 3. At x equals to 3. At x equals to 3. So what is this? This is point of discussion. And what is this? This is the definition of the function. Now how do they define? So let's go for solving problem. I will write answer as, see, I will write given. So what is given? I write the definition of the function. I am given f of x to be x square minus 9 upon x minus 3 for x not equal to 3, and it is 8 for x equal to 3. We need to understand in detail what they are, how they are defining the function. See, they say that if you draw the number line here, so see, what do they say? On the line somewhere you will have 0, definitely yes, 1, 2, 3, 4, 5, 6 and so on till positive infinity. Then this side you have all negative numbers, -2, -3 and so on. This will take you to the negative infinity. It takes you to the negative infinity. Now what they say is,
Sir, I can't see your screen.
Yes, sir.
so here, you know, we have, the question says the function is defined as f of x is x square minus 9 upon x minus 3 for x not equal to 3. The function f of x is this. The function f of x is this for x not equal to 3. So come on, let us come on this number line and tell me which number on the number line you have x not equal to 3. This is very important, students. You need to be focused. They say f of x is this function. F of x is x square minus 9 upon x minus 3 for x not equal to 3. That is when x is not equal to 3. Now tell me on this number line, which point is x not equal to 3? The fact is, except this point, all the points are x not equal to 3. Why? Because this is the point where x is equal to 3. So elsewhere x is not equal to 3. See, this direction on the left of x equals to 3, all the points x is not equal to 3. This direction on the right of x equals to 3, this direction that is on the right of x equals to 3, every point x is not equal to 3. Everywhere x is not 3. X is some other number, it is not 3. Same way here also, x is some other number, it is not 3. So when they say f of x is x square minus 9 upon x minus 3 for x not equal to 3, they actually saying that when x is lesser than 3, or x is greater than 3, the function is defined as x square minus 9 upon x minus 3. What I understand? I understand x not equal to 3 is all the numbers on the left of x equals to 3 and all the numbers on the right of x equals to 3. So x not equal to 3 is nothing but x less than 3, x greater than 3. X less than 3, x greater than 3. All these numbers are x not equal to 3. Only one number is x equal to 3. Here they say function is defined to be this. Function is defined to be this for x not equal to 3. It means function is this for x less than 3 and x greater than 3. So on the left of x equals to 3, on the right of x equals to 3, the function is this only. It is this. So what I understand? I understand on the left of x equals to 3 and on the right of x equals to 3, the function has same definition. What I will say that function has same definition on the left and on the right of x equals to 3. I will write here. Let me write a note for this definition here. Here on the left of x equals to 3, that is when x tends to 3 negative, and on the left hand side and on the right of x equals to 3, that is when x tends to 3 from right, the function f of x has same definition. It has same definition. It is not changing the definition. That one has to understand. I hope you follow what I said just now. On the left of x equals to 3, that is x tends to 3 negative. That is when x is lesser than 3. On the right of x equals to 3, that is when x tends to 3 positive. That is when x is greater than 3. The function is same. This you need to understand. Okay. So remember students, whenever they say x not equal to 3, you should understand it is x lesser than 3 or x greater than 3. If they say x not equal to 3, it means x can be any number other than 3. And when you know x is any number other than 3, it means x is either lesser than 3 or greater than 3. Okay. So I would request you, I would suggest you to write the definition and also write this point. Okay. And draw this diagram in short. Draw this diagram in short so that you will understand this concept. Please do that. So here I tried to explain the given function definition with the help of a graph. See, they say function is x square minus 9 upon x minus 3 for x not equal to 3. Now you all know x not equal to 3 is either x lesser than 3 or x greater than 3. So when x is lesser than 3, see, this is infinite numbers x less than 3. So for all these numbers, what is f of x? F of x is, for all these numbers, remember students, f of x is x square minus 9. It is x square, f of x is x square minus 9 upon x minus 3. That is, here I have somewhere minus 7. Now, if I want the value of function when x equals to negative 7, remember, I will substitute in this. Here I have negative 1. Even for negative 1, if I want the function value, I will substitute x equals to negative 1 in this. Because on the left, the function is this. Next. What is the next? They say When x is greater than 3, the function f of x is once again same. What is it? It is x square minus 9 upon x minus 3. So on both the sides of x equal to 3, say here x equals to 3, and the left of this, right of this as x not equal to 3. On both the sides, the function has same definition. Okay. Further, what more they say? They say when x is equal to 3, it is given in the next step. You can check. When x is equal to 3, they say the function is equal to 8. The function value is 8. So what will happen? When x value is 3, the function value, they say it is equal to, the function value they say it is equal to 8. So when x is 3, function value is 8. I have to find whether, I have to examine whether the function is continuous or discontinuous. Okay, so I will start with the solution here. You know, what is the definition of continuity of a function at x equals to 3? You know, a function f of x is said to be continuous at x equals to 3 if what? If limit f of x tends to 3 is equal to f of 3. The function would be continuous at x equals to 3 if limit f of x when x tends to 3 is equal to f of 3. Okay. So this left hand side and right hand side I will find if they are equal, the function is continuous. Okay. So let me now find out this one. Okay. This is not the part of the solution. It is only for my reference I wrote. Okay. So I will go for the left hand side. I will find out. Okay. Let me solve it here. So I will find out limit f of x, x tends to 3. Limit f of x, x tends to 3. The question is, can I find directly limit at x tends to 3, or I will have to find left hand limit and right hand limit? Will I have to find left hand limit and right hand limit, or I can directly find the limit at x tends to 3? The answer is I can directly find. Why? Because see students, when x is approaching 3 from left, when x is approaching 3 from left or x is approaching 3 from right, the function is defined as same. You know, both the sides, it is the same function. When x is approaching 3 from right, the function is this. When x is approaching 3 from right, left, it is same function for left and right. So I can directly find out the limit value, and it is limit x tends to 3. What is f of x? X square minus 9 upon x minus 3. So I will get limit x tends to 3, and this I will write as x square minus 3 square upon x minus 3. So I will get, what I'll get limit x tends to 3, and here I have x minus 3 into x plus 3, and upon x minus 3 cancels. I write here, since x tends to 3, what do I write? I write since x tends to 3, x is not equal to 3, x minus 3 is not equal to 0. So cancellation of factor is allowed, because that what I cancelled is not 0, it is only approaching 0. So the next step you get the next step as limit x tends to 3 and x plus 3. Now see, you don't have 0 by 0 form. Here I had 0 by 0 form. So the factor responsible for 0 had to be cancelled. I have taught you all this in limits. So the factor responsible had to be cancelled, which was x minus 3. Now I will evaluate the limit. So limit when x tends to 3, x is 3 and here 3. So what is the limit I got here? I got here, therefore limit f of x when x tends to 3 is equal to 6. This is number 1. After this, what is next step? Students, what is the next step? The next step is, now I will find out f of 3. I will now find out f of 3. See, I found out this. I just find out this one. Now I will find out this one, f of 3. Let's see what is f of 3 equal to. I write here. See, it's given. f of 3 is, you all know, f of 3 means f of x for x equals to 3. What is f of 3 meaning? F of 3 is f of x when x is equal to 3. And you know in the definition they have given, when x is 3, f of x is 8. Check this. So here we have, therefore, f of 3 is equal to 8. This is number 2. Now I write what? From 1 and 2. From 1 and 2, limit f of x extends to 3 is not equal to f of 3. You check this, students. Limit value is 6. Limit value is 6. And what is the f of 3 value? It is 8. I will write, therefore, the function f of x is discontinuous. It is discontinuous at x equals to 3. Very simple solution, students. Very simple. Solving this, it's a hardly matter of 4 to 5 minutes. But understanding this is a big deal. Now I will tell you what is happening. See, I will tell you, and this is so very interesting. You will really like it. See here. You got the limit value as 6. You got the limit value when you found limit of f of x when x tends to 3, you got 6. What does it mean? It means that when x is approaching 2, it means when x is approaching 3 from either side, when x is approaching number 3 from either side, the function is approaching 6. As x tends to 3, function is tending to 6. Now you can check where is 6 on the number line. Where is 6 on the number line? On the number line, on y-axis, 6 is here. You check this, 6 is here. So when x is, look at this equation. We got the limit as 6. So as x is approaching 3, f of x has limit 6. F of x is approaching 6. It means it could be, the function could be going like this. The function could be going like this. You check this. See. As x is approaching 3, the function is approaching 6 from the left and also from the right. It could be something like this. See, the function has a limit 6 from either side. From either side, the function is approaching 6. That's why its limit is 6. When x tends to 3 from right, when x tends to 3 from right, see this. When x is tending to 3 from right, the function is approaching 6. And when x tends to 3 from left, see, the function is once again approaching 6. But that gives you only the limit value, because still there is a gap here. These two branches will keep approaching each other, but they cannot touch each other. They cannot touch. And they will always remain away from each other, because this point is here. What is f of 3 value? F of 3 value is 8, and hence the function is discontinuous. Remember, if this f of 3 had been 6, if it was defined that way, I'm just saying, if it was not 8, think if it was not 8 and it was 6, what would have happened? This point would have come here, and that makes the function continuous. You understand? It makes the function continuous, which is not the case. No worries. I hope you followed it. You can copy this whole thing. Very interesting. So now we have another question here to be solved. Question number 2. The question says, examine whether the function is continuous at the points indicated against them. This is question number 1. There are total 3 questions. I wrote the first one here. The given function is this with the given condition as this. And here we have the indicated point. What we have to do? We have to examine whether the function is continuous at the indicated point against them. So my aim is to examine if this function here is continuous at x equals to 2. How do I examine? See students, it is all by definition. I have to examine at x equals to 2. So I will once again do the same thing. I will write the definition of continuity of f of x at x equals to 2. I know a function f of x is said to be continuous at x equals to 2 if limit f of x, x tends to 2 is equal to f of 2. Okay, so I will have to find out first the limit part, then f of 2. Okay, so I will begin with the limit part here first. Okay, so here I write answer. I will start with the definition given for the function. How is the function defined? They say f of x is x cube minus 2x plus 1, x cube minus 2x plus 1 if x is lesser than or equal to 2, and it is 3x minus 2 if x is greater than 2. Now you will notice that sometimes it is given if, sometimes it is given for, sometimes they do not write anything. They simply write in the first line they will write x lesser than or equal to 2. In the second line they write x greater than 2. This all mean the same thing. Okay, that is when x has these values, when x is equal to 2 or lesser than 2, the function is this, and when x is greater than 2, the function is this. Okay, I will go for the limit part. Now here I understand, since the function has different definitions on the left and right of x equals to 2, you check this. See, on the number line you have somewhere 2, on the number line you will have somewhere 2. Now what you notice that when x is equal to 2 and lesser, x is equal to 2 and lesser, the function is here. But when x is greater than 2, my dear students, when x is greater than 2, that is on this side, the function is this. It means the function is changing its definition on the left and on the right of x equals to 2. That means we cannot find the limit here directly. We'll have to find the left hand limit and right hand limit. Okay, so here I begin as follows. I will write out the left hand limit when x tends to 2, that is limit x tends to 2 negative. So here I begin with, I will write here limit f of x, x tends to 2 negative. But remember, my aim is this. Okay, but here I'll have to find left hand limit and right hand limit both. I explained you why. Because on the left of x equals to 2 and on the right of x equals to 2, the function has 2 different definitions, and that you can know. Students, remember, every single time you have lesser than equal to, greater than, or greater than equal to lesser than, you should understand that it is the function having different definitions on the left and on the right. On the other hand, when you do not have such a thing, see here we did not have like that. Here we did not have. Here what we had x not equal to 3. So when it is like this, then you should understand that the function has same definition on the left and right. Okay, don't worry, slowly and slowly you will get a hold on it. So limit x tends to x tends to 2 negative, and what is f of x? For this, the function is x cube minus 2x plus 1. Now I will evaluate. So x is approaching 2 from left, but it is ultimately approaching 2 only. So I will write 2 cube minus 2 into 2 plus 1. So it is 8 minus 4 plus 1. That is 5 plus 1. That is 6. So what I got? I got the left hand limit as 6. I got the left hand limit here equal to 6. Then what I will do, students? Okay. Now, next, what will I do? Very simple. I will now go for the right hand limit. I will find out limit f of x when x tends to 2 positive. You know, when x is approaching 2 from right, the function is 3x minus 2. It is 3x minus 2. So that is 3 into 2 minus 2. So 3 into 2 minus 2, that is 6 minus 2. Okay, here the left hand limit is 5. Here we got, right? This is 5. And here the right hand limit we found. What is it coming? 6 minus 2 is 4. So I have limit f of x, x tends to 2 negative, 2 positive is 4. So this is 1, where I have the left hand limit at x tends to 2 negative. I write this as equation number 1, and here this is equation number 2. Now I write from 1 and 2. From 1 and 2. What am I noticing, students? I am noticing that left hand limit at 2 is not equal to right hand limit at 2. I will write limit f of x, x tends to 2 negative is not equal to limit f of x, x tends to 2 positive. This implies, therefore, limit f of x, x tends to 2 does not exist. And remember, student, if the limit does not exist, there is no question of continuity. Why? Because then there would be a jump. I explained this to you in the last lecture. There would be no question of continuity. So here what I will say next as therefore the function f of x. Now see, students, since the limit does not exist, there is no point finding f of 2. There is no point finding f of 2. The function is discontinuous at x equals to 2. I will write, therefore the function f of x is discontinuous at x equals to 2. That is it. I hope you must have followed it. Please write this, solve this. This is question number 2. What we have to do, we have to examine the continuity of function at x equals to 1 at the point indicated against the function. So this is function. How we will do it? See, I'm not going to give you the complete solution. It is very simple one. See, the first thing you have to do is you will write the given function. So you will copy this whole thing here. You will write the given function here, right? So once you write the given function, and you have to examine the continuity at x equals to 1. The question is still the same. This is the question, main question. Examine whether the function is continuous at the points indicated against them. So what is the point here indicated against this function x equals to 1? I have to examine continuity at x equals to 1. How will I examine? Remember, I examine the continuity by definition. What is the definition of continuity of a function at x equals to 1? It will go as follows. Listen, a function f of x is continuous at x equals to 1, if limit f of x, x tends to 1 is equal to f of 1. So what I will do, I will first find out this. And remember, when I'm going for this, I don't have to find the left hand limit and the right hand limit at 1. No, I will not have to find these two here. I will directly find this. Why not to find this and this? It is because on the left of 1, It is because on the left of 1 and right of 1, the function is same. The function is same. See, they have said x not equal to 1, function is this. They have said x not equal to 1, function is this. It means x less than 1, x greater than 1. What is meaning of x not equal to 1? It means these two, and for both the function is same. So we will not have to find this two. We can directly find here. They are going to be same. So we will directly find the limit f of x extends to 1. And then we will find f of 1 and check whether they are coming equal or not. If they are coming equal, the function is continuous at x equals to 1. And if not, if you are getting them not equal, then the function is discontinuous at x equals to 1. Okay, I hope you will do it. You will all try this. And for evaluation of limit, it's going to be very simple. You have quadratic in numerator, so you will factorize. You will first check every time, you know, if you're going for limit problem, then you know you will have to check whether it is giving you determinate or indeterminate form. If it is giving you indeterminate form, then you will go for removal of that indeterminate form. There are several methods. One of them is cancellation of zero approaching factor. Okay, see, if you want to learn all that, then you will have to watch my videos on limits. It is all explained in much detail there. Now we go for next question. That is question number 3. The third part of second question says the function is f of x equals to x upon tan 3x plus 2 for x lesser than 0, and it is 7 by 3 for x greater than 0. We have to examine the continuity at x equals to 0. How we will examine? By definition. What is the definition of continuity at x equals to 0? See, you have to examine at x equals to 0. So at x equals to 0, what is the definition of continuity? Please just remind yourself. So here we have to examine the continuity of the function at x equals to 0. Definition of continuity at x equals to 0 will be a function f of x is said to be continuous at x equals to 0 if limit f of x tends to 0 equals to f of 0. That is, the number which f of x is approaching when x approaches 0 should be equal to the number which f of x is taking when x is taking 0. So I will first find out the left hand side, which is the limit part, and then I will go for the right hand part. So here I will go for, see, the solution begins. In the solution, you know, first we will write the given function. Given f of x is x upon tan of 3x plus 2 for x lesser than 0, and it is 7 by 3 for x greater than 0 equal to 0. So I will go for limit. See, here I will have to find left hand limit and right hand limit. I cannot find directly this limit. I will have to find the left hand limit at 0 and the right hand limit at 0. Why? It is clearly indicated that when x is less than 0, the function is this. And when x is greater than 0, the function is this. Very simple. On the left and the right of the value x equal to 0, the function has a different definition. On the other hand, think if it was given this way. Okay, just assume if it was given x function is this for x not equal to 0. Okay, just assume that if it had been given this way, f of x is this for x not equal to 0, and f of x is this for x equal to 0. In such case, I would not have to find the left hand limit and right hand limit. No, then I would not have to find. Why? Because once they say x not equal to 0, function is this, it means x not equal to 0 means x less than 0 or x greater than 0. The function is this. For x less than 0, it is this. For x greater than 0, it is same. It means the left and the right, the function, the left and the right of 0, the function is same. Then why find two limits? Then find just the limit, because even if I find two limits, I would be writing the same function, so I would be getting the same answer. So, but that is not the case here. So here what I'll have to do, I'll have to find the left hand limit. So I go for, see, I will go here for limit x tends to 0 negative. I will find out x tends to 0 negative. See, to find limit f of x tends to 0, first I will find limit f of x when x is approaching 0 from the left, 0 negative f of x. This will be limit x tends to 0 negative, and you know when x is approaching 0 from left, x is less than 0. For x less than 0, what is the function? See, for x less than 0, the function is x upon tan 3x plus 2. Now I will write separate limit. I will write the separate limit here. So see what I will get. I will get, so here I'll get limit x tends to 0 negative x upon tan 3x plus limit x tends to 0 negative 2. In the next step, what will happen? See, this is x. I will write this as, so limit x tends to, I will write here limit x tends to 0 negative 1 upon tan 3x upon x. Okay, see, x upon tan 3x. See students, when I'm teaching you all this, I assume that you are knowing a little bit of limits. In case if you are not thorough with it, how to evaluate limit, then you should watch those videos from the limit. And here you have limit x tends to 0 negative 2. Now see here, why I did this? Because okay, I will tell you, because when x is approaching 0 from the left, it is actually x is approaching 0. So the numerator is going 0. In the denominator, it is 3 times of 0, which is 0. Tan of 0 is 0. So what you are having? You are having 0 by 0. And when you have 0 by 0, you will use the result here. Which result? Limit theta tends to 0. Do you remember that? Limit theta tends to 0, tan of theta upon theta equals to 1. Okay, so here I have tan 3x. What will I do next? What will I do next? I will try getting 3x in the denominator. Whatever you have new in numerator, you should try to get the same in the denominator. So see, the next step I will have, okay, numerator is 1, leave it here. Limit x tends to 0 negative, and tan 3x upon x it is. So I multiply, I'll multiply 3 so that it becomes 3x. This is the condition. Whatever angle you have with tan, you should have the same in the denominator. And as you are multiplying 3 here, you will multiply 3 here. What more? And this side you will have limit x tends to 0 negative 2. Now I will apply the limits. Applying limits, what I'll get? I will get limit f of x tends to 0 negative is equal to, this is 1 upon, this whole thing is 1. Here you have 1. So 1 into 3. And here you have, when x is approaching 0 from left, what will be the limit of 2? 2 will remain 2. So the final answer you have is 3. And here you have 1 plus 6. That is 7 by 3. The left hand limit you are getting as 7 by 3. Okay. The left hand limit you are getting as 7 by 3. Now what you will do? You will go for the right hand limit. You will go for the right hand limit. This is 1. The right hand limit is limit f of x when x tends to 0 from right. Now you know when x is approaching 0 from right, x is greater than 0. X is greater than 0. And you know for x greater than 0, what is the function defined as? See students, for x greater than 0, the function is defined as 7 by 3 only. So here I'll write 7 by 3. So when x is approaching 0 from right, it is 7 by 3. So you have here, so limit f of x, x tends to 0 positive is 7 by 3. This is number 2. So we got the left hand limit and right hand limit. See, this is a constant function 7 by 3. This is a constant function 7 by 3. There is no x in this. It will remain what it is. So here I write, therefore, limit f of x, x tends to 0 negative is equal to limit f of x, x tends to 0 positive. Okay. And that is equal to, both are equal to 7 by 3. It means the limit at 0 exists. I will write therefore limit f of x, x tends to 0 exists. And what is its value? Limit f of x, x tends to 0 would be equal to 7 by 3. It is 7 by 3, equation number 3. Finally, after this, see, I found this. What does that mean? I have found this side of the limit. Now I'll go for the right hand side. So I will write here. Now I will write here f of 0. I want f of 0. See, I want f of 0. What is f of 0? F of 0 is f of x when x is equal to 0. What is f of x when x is equal to 0? When x is equal to 0, see here in the definition, everything is given. When x is equal to 0, f of x happens to be 7 by 3 only. So we got therefore f of 0 is 7 by 3. F of 0 is 7 by 3. This is number 4. Okay. So now we write therefore from 3 and 4, limit f of x, x tends to 0 is equal to f of 0. Therefore, the function f of x is continuous at x equals to 0. It is continuous at x equals to 0.